Okay, Earth Science time. Today we're talking about the rock cycle, so please write down, we're going to do this one in dark blue, rock cycle. The rock cycle goes round and round. The objective that we will endeavor to meet, describe stability and change in matter cycles. Describe, so please write the objective down as well, describe stability and change in matter cycling. You can see that probably that the key noun, I mean it's a noun based on a verb, but the key word in both our title and the objective is what? What is the topic of today's conversation? Well, cycling in general, yeah, but we're talking about the rock cycle. What does it mean for something to cycle? What's a cycle?
Circle.
You guys related to the word for circle? What else?
They go round.
Go round.
Like a continuous motion.
Continuous, yes. And not only continuous, but
Non-stop.
repeating. Yes, that's exactly what I was looking for. Thank you. So anytime we're talking about something that is cyclical in nature, it is continuous and repeating. We can think about, well, one thing is that the cycle of the way we do this class. We have a lab. You remember doing the lab? We have a lab. We have some assignments from the book. We do the discussion. We go over the assignments from the book, and then we take a test. And then we start over with vocabulary, lab, assignments from the book, discussion, review, test. So that's a cycle. It repeats. It's continuous. I mean, it will eventually stop in May, but then I'll do it again. And it also repeats over and over again. We did it at first for the Earth systems in general. Then we did it for fossils. Then we did it for plate tectonics. And then we did it for minerals. And now we're doing it for rocks because this is a continuous and repeating cycle. So when we're talking about the rock cycle, what do you think are the nodes on the cycle? Like the cycle I was just talking about of this class are test, vocab, lab. Those are the nodes on the cycle. What do you think are the nodes on the cycle for the rock cycle?
Weathering and erosion.
Okay, so there are processes, which I'm going to put in, I think I'll put those in pink. Some people call this magenta. I call it pink. I'll put the processes in print, and I'll put them in pink. So we have here weathering and erosion. Are those the same thing?
No.
No. Weathering and erosion are not the same thing. They are related processes, but they are not the same thing. You need to be writing this down. Weathering, let me define for you, and you should probably write this down. I won't have room on my diagram, but weathering is when rock material breaks down into sediment. That's the definition of weathering. You need to know that for your test, so you should write that down somewhere. Weathering is when rock material breaks down into sediment. So rocks become sediment is weathering. Okay, what's a way we could remember that?
Sedimentary.
Weather breaks things down.
Yeah, think about the weather. They're not the same thing, but think about the weather breaking things down. Maybe think about rain coming down on a rock and little chunks getting broken off, or snow breaking a rock open. So weathering is when rock material gets broken down to sediment, and erosion is the transport of sediment. What's transport mean? Movement. Erosion is the displacement, the transportation, the movement of sediment from one location to another is erosion. Are there lots of different ways that the rock can be broken down? Lots of different ways a rock can be weathered?
Yeah.
Are there lots of different ways that a rock can be moved? Yep. Are these two things related?
No.
Yes. But are they the same?
No.
No. They are related but not the same. So processes I'm putting in print and in pink. What other processes do you think are going to be on our diagram of the rock cycle? Okay. Could you tell me in more layman's term what that is? You're right. We could definitely put the word metamorphism on here, but what does that entail? No, that's for sedimentary. But try again.
So the compaction.
Heat and pressure. I'm actually going to, we talked about this a little bit in the lab. I talked about this with some individuals. Heat's always present. Like heat is a relative term. Is something hot or not? That depends on the circumstances. But I'm going to put extreme heat and pressure. And that is going to be one of our processes.
Isn't that regional?
It could be regional. It could be contact metamorphism. It could be hydrothermal. Metamorphism. It could even be impact metamorphism, which is the coolest. But we'll talk about those in a second. What other processes should be on our rock cycle in general? You already said another pair. Compaction and cementation. Okay? Yeah, that we're doing processes right now, and then we'll get to some of the nouns. I was going to do it the other way around, but it doesn't really matter. What other processes should be on our diagram? What other things do rock materials do on or under Earth? Melt, and then melt, and yeah, we could put freeze. We could put cool. I'm going to put crystallize. I'm not going to put crystallize. I'm going to erase crystallize. I'm going to put cool. You could put freeze.
I think putting crystallized would be a terrible idea.
Thank you, Gunnar, for your feedback. I appreciate that. In the color, can you see the pink on the screen? Okay, can you tell me? I can't. One of the disadvantages of me having in my room, so okay, you can tell. Oh, I should zoom it in so that people can actually read it, though. Stand by for zooming. There we go. Okay, in green. Oh, and is my mic picking up? That would be something I should have looked at years ago. Okay. In dark green, you might even say Christmas green. I don't know why I would say that. In happy green, we're going to put now, in cursive and happy green, we're going to put the products, the nouns that go with this. So these are, I mean, some of these words are nouns, but in general, these processes are verbs. These are things that happen, things that happen. Now, the things themselves I'm going to put in green and in cursive. So what kind of things, what kind of physical products come out of this? There are three major ones. Sedimentary, I'm going to put over here. Sedimentary rock, igneous rock, and metamorphic rock. What other nouns are there? So we have the kinds of rock. Oh, I meant to do that in cursive.
Now restart.
Now restart the video. Cut. I'm going to redo them all in cursive. I have to cut this. Metamorphic. I even said I was going to do it like 20 times, and because of rope, sedimentary rock, igneous. You know, this is actually not the end of the world. It's taken longer for me to complain about it than to actually do it. As is the case, you should learn that lesson that I have yet to learn as a 33-year-old human being, that you, as a 33-year-old baby who's still learning, learn, unlike I did, that it actually takes longer to complain about things and then to explain them afterward than if you just did it or even redid it. What other materials, what other products, what other physical things could be on here that aren't our specific kinds of rocks? Are there any others? Well, there are. So,
No, I said there's not.
what else can you think of? What other things are there on the rock cycle that aren't rocks themselves?
Minerals.
No.
Okay, mineral. No, I wish that you were okay. What kind?
Yes.
What about when the rock melts, but it has not yet cooled? There we go. Let's put magma on here. What else could? What about when the rock has weathered and eroded, but has not yet compacted and cemented? Dirt. We would call that better though. Maybe sand, maybe gravel, maybe dirt. Sediment.
I hate you. Yes.
Okay. I think that's probably good for now. Of course, there are more processes and there are more nouns, but I'm going to now use my black marker of science, and we're going to connect these.
The Grinch color.
I thought green was the color of the Grinch.
Well,
I think you've been watching. This is the Krampus color, yeah.
we hate Christmas.
I do not hate Christmas. I do hate Santa Claus, and this is recording, and I will go on record as saying I despise Santa Claus. Okay, now let's connect these. Let's connect these. Let's start with igneous rock because I have it in the top right.
Not so cool and magma.
Yeah, so let's say what can happen, what kinds of things, what kind of processes, the pink ones, can happen to igneous rock? Can igneous rock melt and cool? Yep. What would it become if it does that?
Magma.
Well, it would become magma, and then when it cools, it would become igneous rock again. So can igneous rock become igneous rock? Yes, that's part of the rock cycle. What about if igneous rock was on the surface and it weathered? What would it become? Sediment. And then what if that sediment was moved and then compacted and cemented? What would it become? Sedimentary rock. Can igneous rock become sedimentary rock? Yep. What about if igneous rock were subjected to extreme heat and pressure without melting? Metamorphic rock. Can igneous rock become metamorphic rock? Yes. We're done with igneous rock. What about metamorphic rock? What if metamorphic rock were subjected to weathering? It would become sediment, and the sediment would then erode, compact and cement, and become sedimentary rock. I think you see where this is going probably. What if metamorphic rock melted? What would happen if metamorphic rock melted? It would become magma, and then when that cooled, it would become igneous rock.
Metamorphic rock.
What about if metamorphic rock were subjected to extreme heat and pressure?
Do it. Do the arrow. Do it.
No, without melting. I should put that in parentheses here. Without melting. Subjected to extreme heat and pressure without melting, all I did was add this other double-sided arrow. Can metamorphic rock become other metamorphic rock?
Yeah.
Yes, it can. Now, what about sedimentary rock? What if sedimentary rock melted? It would become magma. And what if that magma cooled? Would it become? Sure it would. What if the sedimentary rock were subjected to extreme heat and pressure? It would become metamorphic rock. What if the sedimentary rock were weathered? Can that happen? Yep. It would become sediment. It would then erode, and it would become compacted and cemented and become sedimentary rock again.
What?
Any of these, basically, igneous rock can become igneous rock or sedimentary rock. Sedimentary rock can become sedimentary rock or metamorphic rock. Metamorphic rock can become metamorphic rock or igneous rock. Also, sedimentary can become igneous, igneous can become metamorphic, and metamorphic can become sedimentary. It's a cycle. Do you see? Now, I intentionally drew this like a schizophrenic person from a movie would do it, but it does. In nature, this is happening continuously, and if you look at it on the broad scale, you might even say chaotically all the time, but it's actually an understood and discrete process. Let me show you a sticker I have on my door. Let me show you an example of the callus being in chaos on my door. It says, confusion. The camera won't pick this up, so it won't even tell I'm doing this really awesome pose. Confusion is just complexity before you put your curiosity to work. That's one. So if you're confused about this, that's just because you haven't put your curiosity to work. Don't touch that. And then it says, I choose to embrace ambiguity with patience and courage. And that means that even though some of these things mean the same thing as others, and some of them you don't quite understand yet, it's okay, because they are all related. These are discrete processes that once you understand, even though they all happen at once, seemingly chaotically, there is an order, as it were, to the madness. Now, we're going to get into the detail about what the products of these are, but do you have questions about the rock cycle? This is the most important thing. We're going to get into more detail both now and when we do our lab about the specifics of this, like what kinds of rocks happen. But do you have questions about this?
No.
Does anyone have a question about the rock cycle itself? Does it make sense to you that probably the main thing that people don't understand is that these can, in fact, probably the most common is that individual rock types, igneous, sedimentary, or metamorphic, just become subjected to the same forces again and get the same kind of rock out. Questions? Erase. Okay, which one do you want to start with? We might run out of time before we get to all of them. We probably will. But which one do you want to start with as far as the three broad categories? Metamorphic it is.
Is magma considered rock?
So this was a really good job erasing.
No, it's a liquid.
Let's do metamorphic in brown.
Ew. Alright, throw that marker away now.
Metamorphic. I'm going to actually do a better job of erasing the rest of this. Metamorphic rock. So metamorphic rock, you'll remember from just a second ago, are those rocks that have been subjected to extreme heat and pressure without melting. They can't have melted. What if the extreme heat and pressure causes the rock to melt? Well, that's fine, but it's not a metamorphic rock. It's an igneous rock. Well, it's magma, and then when that cools, it's an igneous rock. So metamorphic rock are subjected to extreme heat and pressure. Rocks in general, I forgot to say this from the outset, but unlike minerals, which had a specific set of criteria that it had to be, rocks we just generally agree are any solid earth material. So if something is solid and naturally occurring on earth, it probably is a rock. I mean, we might add inorganic to that, but they don't have to be crystalline, unlike minerals. They can be, but they don't have to be. They don't have to be abiogenic like minerals. Coal, for instance, is made from life, but it is a rock. It's a much broader category. Probably the main kind of rocks that we see, we would say are mixtures of different minerals, but that's not the only thing a rock can be. So metamorphic rocks have been subjected to extreme heat and pressure, and they come in two categories. The two broad categories are foliated and non-foliated. Can anyone remember or tell me what is probably the Latin root of foliated?
Fold.
Nope. You can think of it that way, but that's not it. It comes from the Latin word folio, which means leaf. Fold might be a better thing to remember it by, but basically in foliated rocks, you can see individual striations or foliations, we would call it, that are like layers. They're kind of like layers. I'm going to put a squiggly. They're approximately layers. We might call them striations. Those words mean that they have visible lines. They have one axis of the minerals that make it up might have certain axes of cleavage, and in fact one of the ways that foliation forms is that the minerals in their cleavage line up one axis of, I'm just going to put lining up, and I'm going to disable comments for this video because of that. One axis of lining up. So a rock might look like this. Whereas in non-foliated, there are no foliations, as you know, there wouldn't be. So the rock might look like that. The metamorphic rock might look like that. Metamorphic rocks are usually denser than sedimentary rocks. Not always, but usually denser than sedimentary rocks. One of the ways that we tell them apart is that, for instance, the sedimentary rock shale, which is formed from minerals that are going in the same direction, kind of layers of very, very, very small grained minerals. If it gets metamorphosed, it becomes slate. And slate is denser than shale. That's one of the main ways. And as slate becomes more and more metamorphosed, there are different grades of metamorphism. So low grade means little heat and pressure, or relatively little, to high grade, which, can you guess? Yeah, more heat and pressure. Going down this list, we have slate, schist, phyllite, and gneiss. These are some of the main metamorphic rocks. I really wish, Ethan, that you would go to the back closet and you would bring out, there's a big old tote of a ton of rocks, kind of like the mineral box that we was. Under and beside that are two big totes of minerals. Take Ty with you and go, or two big totes of rocks. Take Ty with you, and each of you grab one of the big totes of rocks. So I'd like to show these. Now the ones that don't have, the ones that are unfoliated are, yes, slate, schist, phyllite, gneiss. P-H-Y-L-L-I-T-E is phyllite, and gneiss. Gneiss has the highest grade metamorphism.
This is a nice rock.
Do you know people have made that joke before? Okay, non-foliated metamorphic rocks, usually, there are others, but the most important ones, the ones we talk about the most, are quartzite, which it comes from sandstone. I should draw the arrow the other way, actually. Comes from sandstone, generally. Sandstone's a sedimentary rock. And marble, which comes from limestone, another sedimentary rock.
I'm going to find a video of some...
So, as other rocks are subjected to high heat and pressure without melting, they become these. So sandstone subjected to high heat and pressure without melting becomes quartzite. Limestone subjected to high heat and pressure without melting becomes marble. Maybe granite subjected to high heat and pressure without melting becomes gneiss. We already said shale subjected to high heat and pressure becomes slate. Slate subjected to higher heat and pressure becomes schist. That suggested to higher heat and pressure becomes phyllite, etc., on down the line. Oh, there was another one too. I told you there were two. This is not the one I wanted. Let me give some examples here, if I can find one. This is nice. Do you see how it has little... Is that on the camera?
Yeah.
You see how it has like little stripies? It looks kind of zebra stripe. That's the foliation. Those are the layers. So gneiss is the highest grade metamorphism. That's nice. This one is slate. Do you see how is that on there? Left.
Okay, no, there you go.
Do you see the striations? Those foliations tell us that it's a metamorphic rock. And nope, not this one. Not this one. I mean, it's fine. This one's fossils. Go get another one that isn't fossils.
Oh, it's that rock is so nice.
This one, check it out. This one does not have foliations. Do you see it? Marble. This is marble. Marble is made of the mineral calcite.
There you go.
No foliations.
So fossils usually don't form in fossils.
Yeah, that's a great point. Why do you think, you're right, why do you think fossils aren't normally found in metamorphic rocks? Not never, but not normally. Why? The high heat and pressure. The high heat and pressure that squished these rocks would destroy the remains of any organism. And this one's quartzite, also an unfoliated metamorphic rock. Yes. We still got 10 minutes. Okay. Questions about metamorphic rocks as I erase. Okay, I have a question for you. What color should we do the next one in? What is the next one? What is the next one? Igneous. Igneous in orange.
Can you find a poopy looking brown?
Okay, igneous rocks are those rocks that cool from liquid hot magma. So the rock, when it's liquefied, when gets a high enough temperature that it becomes a liquid, like an ice cube would melt, becomes magma. So these are cooled, usually crystallized, from magma. So a rock that has melted and then cooled is an igneous rock. You have questions, Kimberly? You look like you have questions. Igneous rocks are categorized in two ways. So I'm going to draw this little table here. They are categorized, first of all, by their grain size, crystal size, and then also by their composition. I don't have time for that right now, Ty. I'm sorry.
You want that dog after?
No. Yeah, I do. Go get it. So crystal size goes from glassy to small. Let's put these words actually. Shh. I'm trying to go faster. Intrusive. I'm sorry. Extrusive. Let's write that word. Extrusive. Let's spell it right. Intrusive. And then there are others like porphyry, which you'll have to look up on your own because we will run out of time. And then the composition can be either, the composition, let's start with mafic. We'll define these words in a second. I wanted to get this chart set up first. Intermediate and felsic.
Wow.
So, whoop, 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 whoop. Okay. The crystal size gets bigger depending on how long it took to cool. Do you remember your crystal lab when you did minerals? The longer it takes to form, you did yours from water, but it's the same is true from magma. Nice. The same is true for magma. The longer it has to cool, what do you think? Do the crystals get bigger? Do the crystals get bigger, or do they get smaller?
Smaller.
Let's think about it this way. If you have a little kitten, the longer it lives, does it get bigger or smaller?
Bigger.
Right. If you take the kitten and you stomp it the day after it's born, it doesn't get any bigger. If the rock is stopped crystallizing early in its life, early from its formation, from its magma, it doesn't get very big crystals. The longer it has, the bigger the crystals get. Does that make sense to you? Okay, so where do you think now the biggest crystals would be able to grow? Where it's cold or where it's warm? Warm. Hot. Inside the earth. That's why we call it intrusive. So intrusive means it grew inside the earth, and it has big crystals. Intrusive, big crystals grew inside the earth. What do you think is true of extrusive?
They grew outside.
Yeah, on Earth's surface, cooled down fast, so it has small crystals. Extrusive, small crystals grew on Earth's surface. So the difference between those, if it cools, you know this from Minecraft, if it cools really, really, really fast, like in water, obsidian. This one is all just coal. This is not the box I wanted.
If it cools, there's no other box in
No, there's one other box in there. It's the one I wanted.
What's obsidian?
We'll have to continue this another day, I'm sure. But I'm trying to find one little piece. Yeah, I wish I had you go in the first place, but yeah, this is none of these. This one's geodes. This one's fossils. We'll have to continue this video another time. But basically, a glassy rock. We don't have time for that, Gunner. We don't have time to say bye. Obsidian. If it's glassy, it's obsidian. If it cools so fast that the crystals don't have any time to grow. It's not crystallized. It's just glass.
It's just smooth and flat.
Smooth and flat. An extrusive, I have to look at my table for this now. An extrusive igneous rock with large crystals. No. An extrusive igneous rock with large crystals is called gabbro. An intermediate one is called diorite. And a felsic one is called granite. These compositions, this one's mostly iron, or iron and manganese. This one's mostly silicates. And then intermediate is just in between. Intrusive ones, which would have big crystals, are... Oh, I did this the other way around. This one should be gabbro, diorite, and granite. Like Minecraft, yep, good. I was so happy when Minecraft had the update of putting in gabbro, diorite, and granite. The extrusive ones should be the fine grained ones, are in order basalt, like from a magma flow. Yeah, like the basaltic sea. And then andesite, and then rhyolite. So these ones, usually the breakdown is these are too small to be seen with the naked eye, the extrusive ones, and these ones are big enough to be seen with the naked eye. And then porphyry ones have chunks. They have chunks of some other larger crystal in them. I should put crystals. Large crystals. So this is how we break up igneous rocks. All of them cooled from magma, but depending on where they cooled and what they're made of, they get different rocks. We'll continue this tomorrow. But for now, no, I don't want you to do that.